Good morning. My name is Gaurav Singh Rathod. My roll number is 20951A1223. Today I am going to present a Tech Talk video on the topic hashing for dynamic and static internal table. The subject is the database management system and the code is AIT C01. Let's get started. What is hashing in dbms? Hashing in dbms is a technique to directly search the location of a desired data on a disk without using index structures. So hashing method is used to index and retrieve item in a database, as it is faster to search that specific item using a shorter hash key instead of using its original value. So data is stored in the form of a data blocks whose address is generated by applying a hash function in the main memory location where these records are stored as data blocks or data buckets. So why do we need hashing? Here are the situations in database management systems where we need to apply the hashing method. Like for a huge database structure, it is tough to search all the index values through its levels, and then you need to search the destination data block to get the desired data. Hashing method is used to index and retrieve its item in a database. It is also is the fastest to search the specific item using a shortest hash key instead of using its original value. So hashing is an ideal method to calculate the direct location of a data record on the disk without using any index structure. It is also a helpful technique for implementing dictionaries. Important terminologies in hashing. Here are some important terminologies. Number one, bucket. So data bucket are memory locations where the data records the stored. So it is known as a unit of storage. Key. A dbms key is an attribute or a set of attributes which help you to identify a row in relation. This allows you to find the relationship between two tables. Hash function. A hash function is a mapping function which all the sets of search key to address where actual records are placed. Linear probing. Linear probing is a fixed interval between probes. In this method, the next available data block is used to enter the new record instead of overriding the older record. So quadratic probing. In quadratic probing, it determines the new bucket's address. It helps you to add intervals between the probes by adding the consecutive outputs of quadratic polynomials to starting value given by the original computation. Hash index. In the address of the data block, a hash function could be a simple mathematical function to even a complex mathematical function. Double hashing. The double hashing is a computer programming method used in a hashing table to resolve the issue of his collision. Bucket overflow. The condition of the bucket overflow is called a collision. This is the fatal stage for any static or a function. So now we will see deep about hashing techniques. There are mainly two types of hashing techniques, static and dynamic. In static hashing, the resultant data bucket address will always remain the same. Therefore, if you generate an address for say student ID 10 using hashing function mod 3, the resultant bucket address will always be 1. So you will need to see any change in a bucket address. Therefore, in this static hashing, the number of buckets in a memory always remains constant. So static function static hashing function. So these are some methods. Inserting a record. When a record inserts to be in a table, you can generate an address for the new record using its hashing key. When the address is generated, the record is automatically stored in a location. Searching. When you need to retrieve the record, the same function should be helpful to retrieve the address of the bucket where data is to be stored. Deleting a record. For deleting the record, using a hashing function, you can first fetch the record which is you want to delete, then you can remove the record from the address memory. So static hashing is also divided into two types. These are open hashing and close hashing. We will see about these in details with examples. In open hashing method, instead of overwriting the older one, the next available data block is used to enter the new record. This method is also known as linear probing. For example, in the A2 is a new record which you want to store in this stored. The hash function generated address is 222, but it is already occupied by some other values. That's why the system looks for the data bucket 501 and assign A2 to it. So this is This is linear probing, also called open hashing. Now close hashing. In the close hashing method, when buckets are full, a new bucket is allocated for the same hash and results the link after the previous buckets. Let us see example. In static hashing, suppose we generated an address of IP AMP ID 103 using a hash function mod 5, then it will always be a result in the same bucket address 3. Hence, there will be no change in a bucket address. So hence in this static hashing, the number of buckets in the memory remains constant. This is an example where 5 buckets in the memory you can see stored in a data. So we were doing open hashing, no? For example, suppose R3 is a new address which need to be stored in the function generating address 112. So for R3, but the generated address is already full. So the system searches next available data bucket 113 and assigns R3 to it. Now R3 will stored in the address 113. In close hashing, when bucket is full, the new data bucket is allocated for the same hash, resulting in the links. For example, suppose R3 is a new address that needs to be stored in a table. The hashing function generated the address as 1110 for it, but the bucket is already stored. See, so in this case, a new bucket is inserted at the end of the one. See, two buckets are inserted for storing, making using a link, and R3 will be stored in the address. Now we will see dynamic hashing. So the problem with static hashing is that it does not expand or shrink or dynamically as the size of the database grows or shrinks. Dynamic hashing provides a mechanism in which data buckets are added and removed dynamically and one at demand. Dynamic hashing is also known as extended hashing. So let us see some operation. Querying. Looking at the depth value of hash index and use its bits to compute bucket address. Update. Perform a query as above and update the data. Deletion. Perform a query to locate the address data and delete them. Insertion. Compute the address of the bucket. If the bucket is already full, add more buckets. Add additional bits to the hash values. Recompute the hash function. Else, add the data to the bucket. If all the buckets are full, perform the remedies of static hashing. Hashing is not favorable when the data is organized in some ordering and requires a range of data. When data is discrete and random, hash performs the best. Hashing algorithm has high complexity than indexing. All hash functions are done in constant time. Let us see example. Considering the following group of keys in bucket, depending on the prefix, the last two bits of 2 and 4 are 0. This is 2, this is fourth key, so it will go into the bucket B0. Okay, the last two bits of 5 and 6 are 0 1, so this will go into the bucket B1. Next, the last two bits of 1 and 3 are 10, so it will go into bucket B2, and the last two digits of 7 and 11, so it will go into the B3. So inserting key 9 which has address 10001 into the above structure, since key 9 has hash address this, so it must go into the first bucket, but bucket 1 is full, so it will split. So the splitting will separate 5, 9 from 6. Since the last 3 bits of 5 6 are 001, so it will go into the bucket B1, and the last 3 bits of 6 are 101, so it will go into the bucket B5, and key 2 and 4 are still in B0. The record in B0 is pointed by the 000 and 111 entries because the last two bits of both the entry are 0. Keys 1 and 3 are still in B2. I will repeat, key 1 and 3 are still in B2. The record is B2 is pointing by a 010 and 110 entries. Because the last two bits of both the entries are 10, key 7 is still in B3. The record is B3 is pointed by the 111 and 011 entries because the last two bits of both the entries are 11. Advantages of dynamic hashing. So in the In this method, the performance does not decrease as the data grows in a system. It simply increases the size of memory to accommodate the data. In this method, memory is very utilized as it grows and shrinks with the data. There will not be any useful memory lying. This method is good for dynamic databases where data grows and shrinks frequently. So disadvantages are, in this method, if the data size is increased, then the bucket is also increased. The address of the data will maintain in the bucket address table. This is because the data address will keep changing as bucket grows and shrinks. If there is a huge increase in data, maintaining the bucket address table becomes tedious. In this case, the bucket overflow situation will also occur, but it might take little time to reach this situation in static hashing. So let us see some differences between static hashing and dynamic hashing. A hashing technique that allows users to perform lookup and finalize dictionary sets, and dynamic hashing is a hashing technique in which the data buckets are added and removed dynamically and on demand. Resultant data in the bucket address is always the same. Data bucket changes depending on the records. It is less static hashing is less efficient and dynamic hashing is more efficient. With this, we will conclude our PPT. Hope you like it. Thank you.